Intro Surutsu 1 class. The screen shows a messy dataset filled with errors, missing values, and random noise. Dirty data can be produced as a result of human errors, integration of separated systems, or changing requirements. The scene then transitions to the same dataset, but now organized and clean, while an AI model works smoothly. Data cleaning is a scientific process to explore and analyze data, handle the errors, standardize data, normalize data, and finally validate it against the actual and original dataset. Data is the backbone of any AI project. Without clean and well-prepared data, even the most advanced AI models can fail to provide accurate results. In this video, we're going to explore the importance of clean data, dive into methods of data pre-processing like handling missing values, normalization, and scaling, and discuss the crucial role of feature selection and engineering to enhance AI model performance. Let's get started. Why clean data matters. A dataset from a healthcare system, highlighting missing values, inconsistent data formats, and typos. Show how these errors impact a machine learning model's output. Then, transition to clean, properly formatted data with accurate predictions. Why is clean data so important for AI? The answer is simple: garbage in, garbage out. If your data is messy, your AI model will learn the wrong patterns and produce inaccurate results. For example, in healthcare, messy data can lead to wrong predictions about patient outcomes, putting lives at risk. Clean data ensures 1. Accuracy. The AI learns from the correct patterns. Efficiency. Models perform faster and with fewer errors. Interpretability. Clean data makes model results easier to understand and trust. Example. In healthcare, patient records may be filled with missing values, such as unreported lab results or incomplete medical histories. Before building a predictive model for, say, heart disease, we must ensure the dataset is complete and consistent. Without this, the model may predict poor outcomes, even for healthy patients. This example shows why clean data is critical to ensuring accurate, actionable results. Methods of data preprocessing. One. Handling missing values. Removing the duplicate records or imputing missing value in a dataset is an essential step in an analysis. A table of data with missing values highlighted. Show different methods for dealing with these gaps, such as removing rows, columns, and imputing missing values. One of the most common challenges in real-world data is missing values. Missing data can arise from various factors: sensor failure, human error, or incomplete data collection. However, we have several methods to handle these issues. Removing missing data. If the percentage of missing values is low, you can remove affected rows or columns. Imputation. For datasets where removing data isn't an option, you can fill in the gaps with calculated estimates. Imputation can involve using the mean, median, or mode for numerical data, or more advanced techniques like k-nearest neighbors imputation. Example. In the retail industry, customer purchase histories often contain missing transaction details. Instead of discarding these valuable records, we can impute the missing values based on average customer behavior. This way, AI systems like recommendation engines can continue to provide personalized suggestions without losing important insights. 2. Normalization and standardization. Demonstrate how normalizing the data compresses the range between 0 and 1, and how standardizing data centers it around the mean with a standard deviation of 1. Many machine learning algorithms perform better when the data is on a consistent scale. This is where normalization and standardization come in. Normalization rescales data to a fixed range, typically 0 to 1. Standardization centers the data so that it has a mean of 0 and a standard deviation of 1. In the finance industry, stock prices vary greatly, from pennies to thousands of dollars. If we're building a predictive model to forecast stock market trends, using raw prices without normalization could bias the model toward higher-priced stocks. By normalizing the data, the AI model treats all stocks equally, improving prediction accuracy. 3. Encoding categorical data. Show how categorical data like red, blue, green gets transformed into numerical format using label encoding and one-hot encoding. AI models can't directly handle text data like categories. That's where encoding categorical data comes in. Label encoding assigns each category a unique number. One-hot encoding creates a binary vector for each category, representing its presence or absence. In an e-commerce application, product categories like electronics, furniture, and clothing need to be encoded before being fed into a recommendation algorithm. By encoding these categories, the AI can learn how different products relate to customer preferences. 4. Outlier detection. Show a dataset with 1 or 2 points that stand far outside the normal range. Demonstrate how identifying and removing outliers improves model performance. Outliers, extreme values that deviate from the norm, can significantly impact the accuracy of AI models. In credit card fraud detection, unusual transactions, such as a sudden $10,000 purchase on a normally inactive card, can be flagged as outliers. These extreme values are often indicative of fraudulent activity and must be handled carefully during data pre-processing. Feature selection and engineering. 1. Feature selection. Show a dataset with many columns, then highlight a few key columns while others are grayed out to indicate their irrelevance. Not all features in a dataset contribute equally to a model's performance. Feature selection helps identify the most important variables and eliminate those that add noise or redundancy. By focusing on the right features, we can reduce the complexity of our models and improve their efficiency. Example. In an e-commerce business, customer age and purchase history may be critical for predicting future sales, while zip code might be less relevant. By selecting only the most impactful features, the AI model becomes faster and more accurate. 2. Feature engineering. Show how new features are created from existing data, like converting a timestamp into day, month, or year, or combining 2 features, such as income and expenses, into a new feature, savings. Feature engineering involves creating new features from raw data that better represent the underlying patterns. This process can significantly improve model performance. In the insurance industry, combining features like age and smoking status to create a new variable called health risk score helps predict health insurance premiums more accurately. Example 2. In transportation, we can engineer a new feature like rush hour traffic from a dataset containing timestamps, improving the predictive model for traffic patterns. With this engineered feature, AI can better predict congestion during peak times. Real-world applications of data pre-processing. Data pre-processing is the foundation for successful AI models across various industries. Healthcare. Pre-processing medical data helps predict patient outcomes, detect diseases earlier, and even personalize treatment plans. Finance. In fraud detection, pre-processing financial data is essential to filter out anomalies and identify suspicious transactions. E-commerce. By pre-processing customer data, online retailers can make personalized recommendations, improve customer segmentation, and predict future buying behavior. Data pre-processing is a crucial step in building any AI model. From cleaning messy datasets to selecting the most important features, these techniques ensure that your AI models are accurate, reliable, and effective. Thank you for watching. Don't forget to subscribe, like the video, and leave a comment if you found this useful. See you in the next one.